Good morning, everybody. Mustering up all the energy that I can manage, and my voice is gone before I even begin. Okay, before I totally lose my voice, I acknowledge the traditional owners of this land. I pay my respects to the elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, good morning, everyone. Let's see, who have we got? Chip is here, Independent Tech, Johnny, Frank, Mako, Brian, Sion, some call it Fun is here, Jacob, Aaron, lots of people, Chris S, and I probably missed a few people. Well, welcome to my lab. I don't know how to begin. What do I do? Who is this happy, energetic me? I don't know. I fake it for the live stream. Right before I hit go, I was like, but no. The weird thing is that, but right before doing live streams, I can hardly see out of these glasses. Right before I do live streams, I'm usually feeling like, and in fact this morning, this is how I was feeling. I don't know if I can be bothered today. I just don't have the spoons for it. I don't have the energy, and I can't think of anything to talk about. And why would anyone want to come and watch me talking about nothing anyway? And then I this morning actually I only did the live stream out of a feeling of, this is going to sound really bad, a feeling of obligation. Like, there is the expectation that I'm going to do it. But then when I hit the scene select thing and I actually say good morning, I suddenly feel like, yeah, this is what I want to be doing. It makes me happy to be doing this because I get to talk to all of you, which is really, really cool. It is amazing. I do appreciate this. I know this is kind of a bit of a touchy-feely sort of way to be beginning this, but thank you for coming along. It really does mean a lot to me. The fact that I start this on a Sunday morning and a whole bunch of you get in here and you're in the chat even before I've begun, it's really nice. Yes, as Mako says, talking to people is awesome. Oh, Mike, I'm glad it can make you happy as well. Yeah, it is very easy in these days to be quite isolated and to feel like we're going through all of this alone. And in fact, as I've said before, I started these live streams back at the beginning of lockdown v1.0 here in Australia at the start of last year. And it was partly to overcome this whole sense of isolation. And oh, Jordan said, am I using a different camera? No, it's the normal camera that I use, but I've moved the light panel from there to there, and the position of it is all probably slightly different. I've just been moving things around to try to make it easier to do assembly. I did a whole lot of, I did some camera changes before the live stream on Friday night. And because the Friday night live stream was at a very different time to normal, it was actually a different group of people. There was obviously a lot of overlap. There were a bunch of the usual live stream attendees on Friday night, but there were also a whole bunch of people who said, hey, this is the first time that I've got to see a live stream live. Because normally it's at some crazy hour of the morning and it's just not practical to be awake. And yes, I know there are some of you here right now for who it is 2 a.m. or some ridiculous thing like that. But not everybody can be up at 2 a.m. just to watch a live stream. So on Friday night we had, same amount of viewers. Aaron said actually more. So right now, according to YouTube, there are 45 concurrent viewers. That notification was Elise, one of Chris's carers, arguing with me about chocolate. Totally random thing. So yeah, we got 45 concurrent viewers. We got up to 137 viewers on Friday night for an impromptu live stream with 10 minutes of 10 minutes of warning. Johnny says, it's Saturday night, I'm always awake at 2 a.m. on Saturdays. 8 p.m. in Ohio, USA. Well, that's a nice, respectable time. 8 p.m. is sort of relaxing. You can sit down and dinner is typically done. It's a good time to be sitting around. All right. Oh, some call it fun says, glad you film in a real lab, not a green screen. I've had people accuse me of being in a green screen. I had, where was it? There was an online meetup type group that I did a talk at last year sometime. And I was doing the talk and it was, I can't remember the camera setup, it was something similar to this. And it had all this stuff in the background. And one of the comments was something about, oh yeah, nice green screen lab. And I was showing off some stuff. So I did a camera switch and moved over to here and started showing real things. And in the comments, it was like, what the hell? That's real. It's not a fake, and not just a fake background. Yes. So, Austin said, I missed the impromptu one, had gone to bed just before it started. 6 a.m. your time. You were going to bed at 6 a.m. Okay. That's really pushing it. Now, one of the things that just saw the comment from Station 240. John is so happy. I just had to check if a certain electronics retailer had gone bankrupt. No. The weird thing is that actually wouldn't make me happy. That would make me sad. But let's not get into that. That is quite a squirrel to chase. Talking about the state of electronics parts retailers and the fact that here in Australia, and I'm sure in most parts of the world, it is now very, very difficult to be able to jump in the car, drive down the street and walk into a shop where you can buy electronic parts over the counter. Even with things like next day shipping or something like here in Australia, I can order from DigiKey on DHL or FedEx or whatever, and it usually arrives in about 3 or 4 days. That's a very different experience to being able to get something in half an hour. So I think having, I just think it's a real shame not having stores that we can walk into and just say, I would like some 10K resistors, please. And have them all available right there. And I know that particular business model is a very hard one to sustain. But anyway, maybe I shouldn't chase that particular squirrel. All right, now, because there were a whole bunch of you who were not here on Friday, I'm going to show you something which I did on I set up for the live stream, because what I'm trying to do is rearrange my cameras and things to make it easier to do hands-on practical things. And so this is the trick. All right. Many of you will already know what this is about, but I'm still proud of this. It's one of those things where, you can work on projects that take months and months, and you've got to do all sorts of custom design and fabrication, and things are really, you put a lot of thought and effort into it, and you get some satisfaction out of that. But sometimes it's when you take a really simple thing and whip something together in a dodgy hack and it works in like half an hour that gives you the biggest buzz. All right. Yes, should you show the microscope switcher? Yes, Austin, that's what I'm talking about. So this is one of those things for doing live streams of hands-on assembly. And okay, so if I switch to overhead camera, this is what Austin is talking about. I've got it set up so that I've actually got two cameras in front of me right now. I've got front camera, and then I've got a camera that is a little bit to the side because the field of view looks down the workbench. You can see in the field of view it's coming straight out into the room. If I switch to the overhead camera, the field of view switches to the side, and then I can talk to you there and show stuff on here. But this is the tricky bit. So if I was wanting to give you a close-up view of that, I can move over to here. Oh, I've got to get some focus. Did it work? Yes, it did. It work? No, it didn't. Let's see. Oh, come on. My magic trick is not working. Oh, I know why. I know why. There is a weird focus issue in Mac OS going on with this. So let's see if this does it. Yes, it does. So chuck it under the microscope and we can have a look at my dodgy rework soldering job there. Put it back on the bench. Look at it in the overhead view, and then back under the microscope and back on the bench, and it's all hands-free, totally seamless. So yes, as Dodgy says, it's like having your own cameraman in the lab. Yeah, so the way this is working, for those that didn't see it, I'm going to switch to side view, side camera, so that you get the best view. It's a little bit hard to see, but on the front of the microscope right here is an HC SR04 ultrasonic distance sensor, and there is a white cable here that goes over the back. That runs down and around and under the bench, and it comes to, in fact you can, if I move this you'll just see it. I'll pull it out. That is a Leo stick, so it's an Arduino Leonardo compatible board that's emulating a keyboard, and when I move in front of the microscope, it sends hotkeys into OBS. So if I put my hand in front of it, you'll see it will scene switch. Well, it should. Oh yes, there it goes. Scene switch there. Ah, it's got, I need to do some debouncing on it. Okay, scene switch to the microscope. And then I take my hand away and it sends another hotkey combination to change to the overhead view. So I can change between microscope view and overhead view just by sticking my face in front of the microscope. All right. Yeah, it is pretty dodgy. At the moment, like as I said, I got that working in half an hour, and I haven't done any tuning at all. In fact, in the code where I first set it up, I just picked an arbitrary value of the distance of where it was going to trigger. I think I made it like 9 centimeters or something. I just thought, yeah, that sounds about right, 9 centimeters, put it in. And I haven't changed anything since, so there's no debounce on it. It tends to do some slightly strange things, so it definitely needs a bit more refinement, but I think the concept is good. I think the idea of being able to switch to the microscope, so that the idea is that what you are seeing is what I'm seeing. When I'm at the bench holding the thing, you're seeing the view on the bench. When I switch to the microscope, you're looking through the microscope. So putting your view through mine. So Sion asked a few weeks back, but I don't think I was around if or when I answered. So are you back to individual camera HDMI capture inputs now and not using the ATEM? That's correct. Right now I'm using 3 individual HDMI capture devices. The ATEM right now is sitting on the far end of the bench, and I'm trying to work out whether it is worth keeping it and whether I can incorporate it into the flow of how all of the cameras, yes. Chris said, what about the suggestion to add a camera stream picture-in-picture from your power bench and or scope? Yes, that's what this camera is for. Hang on. I'm going to switch to side camera. This, I'll get the static strap out of the way. This little thing here, that's a USB webcam on an arm pointing at the screen of my oscilloscope. I mean, I've just messed up the position of it now. But if I go to, let's see, can I go, if I go to overhead camera, where is it? I'm trying to find one of the scenes where I have that, is it desktop? Got to move that out of the way. I'm trying to find one of the scenes where I've got the oscilloscope camera set up. Where is it? Not on the front. No, somewhere in here. Oh, I'll just add the scene to this one. Add video source, video capture device. And no, actually, oh, I know why. It's because I've switched computers since I had that set up. But I do have a camera pointing directly at the, I'm going to turn the scope back off again so I don't have its fan buzzing away. But I do have a camera pointing directly at the screen. Yes. And also it's on the network, so I can use, I was doing some testing with this maybe a month ago. I can do captures off the screen and that works, but the rate is really, really low. It's only like 2 frames a second that I can get off the oscilloscope. Yeah, oh, Celtic Bee said, point sensor at chest as your last soldering session kept on switching between microscope and bench every time you raised your head, even though you were still at the scope. Yeah, so I want to, yeah, I need to do some tuning on that. What I need to do is increase the distance, I think, because the thing is that it's only just triggering as I put my face right up against the microscope. And so I need to make it so instead of triggering at 9 centimeters, it needs to trigger at 20 centimeters or something. So that as long as I'm in front of the microscope, it'll be on that view, even if my face isn't right up against it. All right, yeah, as Aaron said, the multimeter has a screen picture-in-picture. Where is that one? I can turn that on if I go to overhead camera. Oh, once again, I may not have it on, actually my front camera, no. I may not have it set up yet on this computer because I, let's see. Add video, no, there was a browser. Here we go, UT61E. I'm going to add it to this screen. There we go. So this is Aaron's amazing multimeter interface. And right now I'm not sending any data into it. But yes, I need to get back to this because this is a project that is so close. We've got the we have the display interface for it, which Aaron has created, and we have the data capture coming off the multimeter. But at the moment, I need to. Oh, and Ben has been working on the packet decoder for the multimeter and in other positions, so we can see your other. Yeah, well, I just dragged this here as a as an example. So where it would actually be, like say if I'll, no, not that. I wouldn't have it in this view. I'd probably have it in another view, like if I went to overhead camera. Let's put it in here. We would then have that, and I would probably make that smaller, bring that up there. In fact, probably maybe not even have my face at all, and have the we could have the oscilloscope under here as well. Yes. So lots of options. Anyway, that's all going to get moved around as necessary. So I'm going to disappear it off that view. Yeah, so the general idea is I want to make it easier, and this is what started, you know, months ago with the UT61E Wi-Fi project. I want to make it easier to be able to do actual live work on the bench And for all of you to follow along at home, watch what's going on. The penguin looks superimposed on the screen. The penguin? What penguin? Was that in here? No? I don't know. I don't understand the comment about the penguin. Yes, all right. Cool. It feels like I've just been, well, okay, it doesn't just feel like, I have been talking randomly. We've been chasing squirrels. Yeah, so, yeah, IDF says my C922 focus is okay, but they won't change focus if I try to hold something up to it to show a close-up. It stays focused on the background that was focused. Yeah, it's on your badge? Okay. Still don't understand. Oh, that badge. Oh, right. I see. That was in the side view. That's why, if I switch to side camera, right there. Yeah. So there's the Tux Penguin on the LCA 2021 conference badge. Yeah. All right, so Cable Tie says, hi folks, catching up on 1.75 times, about 2 minutes 20 seconds behind. So everyone's got to, you've all got to type faster, and I've got to speak faster to keep ahead of Cable Tie. The side view is jumping oddly. I think there might be some weird image stabilization happening with the Logitech camera. The side view is a Logitech Brio webcam, USB webcam. And yes, and the front one is a Panasonic, like a proper camera, running with HDMI capture. Now, I'm stumped. What are we going to talk about? Okay. Okay, a couple of things. Let's do a little update on what happened after the assembly session on Friday, because many people won't have caught up with that. There's been a lot of chat in the Discord, so people that have been in Discord are probably aware of it. But let's go back to the overhead view here, and I'm going to get rid of that multimeter interface because we don't need it right now. And I'll give you time for... oh, Doji said, does the camera in front have a shorter focal length than the previous ones? Yeah, I think it does. It's... yes, is the answer. So it gives that out of focus background effect. You can see on the side camera, which is the webcam, this has a very long depth of field. So you can see the logo in the background is still in focus. But the front camera is like a proper Panasonic G85 with a reasonable lens on it, and the focus is set to here, and then the background is out of focus. Now, overhead camera. All right, the Universal Rack Controller project. Time for a quick update for those who missed the Friday live stream. What we have here is the mostly assembled first prototype of the ESP32 control board that will go in the Universal Rack Controller. And yeah, so this is what I assembled on the live stream on Friday. So we've got Ethernet in here, we've got USB-C for the serial connection. So if you're looking at the rack, this is the front of it. It goes down the right-hand side of the rack case, and then these connectors will be exposed on the front panel, along with a power LED that will be like a bezel sort of style mounted in the front panel above the USB-C connector, I think is the current plan. So there'll be an LED that comes through the front panel here and then plugs into this header just here. So this is just exposing 3.3 volts with a little current limiting resistor. Although my thoughts on this have changed, but oh well. So at the moment, just a single color, like maybe a blue LED going into that for power indication. And then we've got, moving back up the board, We have a breakout here for some extra, some extra I/O. We have 3.3 volts ground, and we've got the first I2C interface. Then we've got the second I2C interface, SCL2 and SDA2. And then we have the second hardware UART from the ESP32. We've got TX2 and RX2. And those were specifically asked for by Ben because they can be used for something like connecting to a KNX interface. So this could be integrated with a KNX-based home automation system. And the first, so the primary serial port goes to USB, and then the second serial port could go to KNX. So that's kind of useful. Back behind here we have the WIZnet W5500 chip, and then some status LEDs just here. And just for the fun of it, on the live stream I pulled out my little bag of random LED colors, the oddball ones, and then put on a whole lot of different things. So we've got purple and orange, there's some slightly unusual green, and I can't remember, but anyway, it was all these LEDs are different, and under the microscope they all, in fact, let's see if this switcher is going to work now. If I lift my head, I won't be able to tell if the switcher has worked. I think it has. Oh no, it switched away again. Yeah, it's definitely needs to be set up to work at a longer distance. So we've got the purple one, which is the activity LED, then you can see a couple of different LEDs in the middle. I don't even know what they are. And I think the bottom one is the orange one for the 100 megabit indication. And so we've got the WIZnet W5500, we've got I2C pull-up jumpers just here. The jumpers aren't in place. I2C breakout, which goes to whatever the thing is, like the light switch board. In fact, I've got one right here. So here's a 24 port light switch breakout, and then this just connects with an IDC cable, goes right in there, and then they'll mount side by side in the enclosure like that, which is very neat and cool. That's worked out well. One thing that's a little bit unfortunate is the position of this connector in relation to the mounting holes on this. Now, I kind of knew this was going to be a problem, but it was a bit constrained by the mechanicals, because what's going to happen is, if I move this over here, the LCD is going to mount all the way down the other end of the enclosure. It's going to be all the way over here, basically mounted like that, about there somewhere. So the ribbon cable is going to come off the back of this, do a right angle, because it'll be folded, run along the back here, come all the way along, come up, and then plug into this connector. And if I get these right in the middle so you can see how they mount relative to each other, you can see if I align the front of the PCBs, so these mounting holes are both 8mm back from the front of the PCB, this mounting hole and this mounting hole are at a different space. They don't align horizontally, and the ribbon cable that comes off this is going to just clear the mounting posts for this board. So it's not too bad. Yeah, the angle doesn't really give you a proper view there. If I move it over here, you'll get less of a parallax error. That basically the cable that comes off this connector is going to run under the back of this PCB, sort of half under it, and right behind the mounting stakes for this. And that's basically as good as I could get it. I would have preferred to have this cable up a little bit higher and then clear the back of it a bit more, but yeah, I couldn't make it go up any higher here because I'm constrained by the SD socket and the PoE regulator. Speaking of which, we've got the SD socket and the PoE regulator. There's the ESP32, just on a Vroom 32 module, and the power supply section. So we've got 12 volts comes in from here. We've got a 5 volt regulator here. So this is an automotive grade linear regulator, because these things are absolutely bulletproof. It'll run a little bit warm because it's a linear regulator, not a switching regulator, but it'll last forever. Like, this thing will never fail. And that then feeds into a 3.3 volt regulator, which runs, you know, the classic little AP2112K, which runs the ESP32, etc. So where we got to on Friday was doing all of this assembly, and we did some preliminary testing. We got the profile loaded into the CP2102N, so that's the USB to serial converter just here, and we loaded code onto the ESP32, so that worked. We tested the SD card holder, that worked. We could get a list of the files on the SD card, and the power supply worked in terms of the voltage regulator. There were a couple of problems. One problem is, one problem was that I couldn't talk to the Ethernet chip. And it turns out that's just a software issue. So since then, I have got this working, and maybe we'll look at that in just a second, because there's going to be a little bit of work to do to get the software to work nicely with this. And the other issue is the auto power source selection didn't seem to work properly. So the idea, what I was trying to do with this bit of circuit here, so this is an LM358D op amp and an FDN340. There's a transistor just there. The purpose of this little part of the circuit is to do auto selection between power coming from USB or from power over Ethernet. And power over Ethernet is effectively the same as feeding power directly in the back here. So if you're feeding power in the back, what you would do is leave jumpers off. The more I think about this, oh no, that's right, this is protected by a Schottky diode. Yeah, that's okay. So there's Schottky diode protection on both. You can see there's one diode there, there's another diode there. These diodes protect the two input sources, the back panel power source and the PoE power source. So if you try supplying power through both of them at the same time, you're not going to send power, or if you send power in either of them, it's not going to send power out the other. So you can't back power through those. They're both covered by those Schottky diodes into the voltage regulator. But the problem that we found is if you plug power in on USB and you send power in through the DC input, either PoE or from the back, it basically how do I describe it? Something is going wrong in this auto power source selection circuit, and it is effectively being like a short circuit, I think, on the USB power, which means that it's hitting the current limit on the USB power source. So I need to dig into that. I have not even looked into that in any more detail to know why. And it may even just be that on Friday I was tired, it was the end of a 3-hour live stream, and I was screwing up somehow. So I need to come back to that part with a clear head, do some investigation of exactly what goes on when power comes in on both of these sources at the same time. So if we're really lucky, it'll turn out there actually isn't a problem. It just looked like there was a problem, but maybe there is. And if there is a problem, I need to work out how to fix it. So yeah, so far we've had lots of success. Oh yeah, and also there's a temperature sensor just up below the logo here, just above the I2C pull-ups. That's an I2C temperature sensor, and that works as well. So we have now verified working USB serial, Ethernet, I2C with a temperature sensor, PoE, like direct injection PoE, we've proven works. I don't yet have the modules that go on here to verify 802.3 AF. Obviously the ESP32 works. So far, this project has been full of success to a kind of scary amount. Now, one thing that I didn't even get to trying to test on the live stream, and I've since tested, is the LCD. And there is a problem here, but it's not a killer problem. I'm pretty sure it's not a killer problem. What you can see here is one of these cheap 1.3-inch LCDs wired directly to the header. So the plan, and this is the same LCD, it's just that it's on a little carrier breakout board that I designed that seems to be not working as I expected. So I need to investigate that some more as well. So we've got, oh, actually this one. I assembled a couple of them. Not put that one aside for now. Okay, this is the carrier board with the IDC cable, and the IDC cable would plug in here if there was a proper socket on there instead of these cables. So I'll show you what happens. What do I need? I need some power, so I'll just plug USB into it. So what I've got, I'll just unplug that to get it out of the way. So what I've got on here right now, loaded on this ESP32, is just a demo program to put text on the LCD. So if I power it up like that, you can see there is text on the LCD. I'll move it back down into the focus area. And it's flipping between white background and black background. If I just, you can see it's gone black now, so it says invert on white text, red text, green text, blue text, and then it just flips to a white background. So we are controlling the LCD, which is good news. But there is a caveat. The caveat is, as I've explained previously, this particular LCD module does not have the chip select exposed. So what's happening right now is that there are 7 wires here going to this LCD. There are 8 wires on this header. The one that is not connected is chip select. And so when the LCD is plugged in on SPI, it assumes that it is the only SPI device. So when you're talking to it, when you've got the LCD running, you can't talk to anything else, which means you can't talk to Ethernet, you can't talk to the SD card. There's no way to select which device you want to talk to. And that is what this little breakout was meant to solve. But it doesn't, as it turns out. So what I did on this module was it has this same LCD on it, but it has this little buffer chip on here, and that is a so yeah, basically it's a buffer that you can enable or disable. So I brought the chip select line in to enable or disable the buffer, so that when the LCD is not selected, it'll be disabled and the LCD will not receive any data. But this doesn't work. The extent of it has been so far that I've plugged it in and discovered that it doesn't work. I've done 0 diagnostics on it. I've got plenty of ideas, and there are some good suggestions. There were some comments. Someone commented that instead of interrupting the data line, which I'm currently doing, so the buffer is isolating the data line, what I should be doing is isolating the clock line. Or maybe I should isolate both. So that is certainly something I can try. I can experiment with that just by doing some cutting and patching on this PCB. So I'm just going to experiment with that. I'm going to hack some bodge wires onto it. And you can see what I've done here is I did a quick test by hacking a bodge wire on that effectively bypasses the thing entirely, so that it's just always enabled. So I've just started with bodging around on that. So I'm pretty sure that it'll be possible to get that working. So solutions to this. Solution 1 is to fix the problem with this breakout so that the chip select works, and continue using this same LCD module. Solution 2 is to change to a different LCD module. And there was a message in, there was a comment, where was it? Was it in Discord? I think, or it might have been a comment on the video. Someone pointed out an alternative module. This is a 1.3-inch LCD. There is a 1.44-inch LCD, which is significantly bigger. It's the same resolution, it's 240 by 240, but it's got 8 pins on it, and it has a chip select. and it's a bit over twice as expensive as this module. So that would be an option. We could just change to a bigger LCD. It's 30, the bigger one is 32 millimeters high if you turn it sideways. So it would just fit within a 1 rack unit case. So that's an option. We could just switch to a different module and then the whole chip select thing goes away. Or we could make our own, which is also quite a viable option. So these LCDs have a controller that is bonded just in under here, under this bottom edge, and it brings out the connections here onto this little ribbon cable that go onto the PCB. And apart from that, this module doesn't have much on it. There are a couple of passives here, just for like mode setting, and I'm not sure what U2 is. I haven't looked at that in detail, but there's nothing much on there. So we could just make our own. If I buy these LCDs bare, not on the module, then we could make a version of this that instead of being a breakout for the existing module, it is the module. We would directly integrate the LCD onto it, and then we've got chip select available, and once again the problem goes away. So then it would all be good. But so there are little things like that that have to be sorted out. But that's kind of to be expected with this sort of project. So this is prototype number 1 of a totally new design. So I'm actually quite surprised at how little fail there is and how little smoke we've managed to let out of the board, which is very cool. And we have working Ethernet. In fact, let's have a look at working Ethernet. I'm going to, what have I got on the other end of this cable? Nothing much. All right. What have I got to do here? Okay, first thing is I've got to disconnect that. No, in fact, just as this is probably going to fail, but just for the fun of it, I'm going to leave that and not disconnect it. Okay, so I plugged in Ethernet. Ethernet is connected at the other end to a switch on my bench. This is probably not going to work because this is still plugged in. Although I think what will happen is Ethernet will work, but because we've got no outline coming back. There's no data line coming back from the LCD. All we're doing is sending data to it. We never actually listen to it. So what will happen is the LCD will get bogus data and it will probably get confused. But I think Ethernet will work. Oh, Aaron says it was Discord, this one. Yes, okay, so in fact I still have it open. I've been ignoring the chat for the last 10 minutes while I've been showing you all of that because I couldn't read it from over there on the bench. If we go to desktop view, yeah, this is the one. And I've had this open in my browser to look at it. So this is the, where is it? Oh, 1.54 inch. It's huge. 240 by 240, and this one has the chip select brought out. So if we look at the pin out here, there it is. There's the CS pin that we need. So this display should just work straight out of the box with our current design. All we need to do is have a cable that goes from this header here. So it would be a super simple breakout. All we'd need is a carrier board with nothing on it but the IDC connector. It would be so easy. And we just make it so that it aligns with the mounting holes behind this. And I am pretty confident that would work. So that is one option, is going for these. The only issue is that physically it's going to start being a tight fit. If we look at the dimensions on here, somewhere it had dimensions. I can't see it. I'm looking in the wrong place. Oh, here we go. Model size, 44 by 32 by 4 millimeters. And the 32 is the number we care about. So it's 42 millimeters that way, 32 millimeters, is that 44? 44 millimeters across ways, 32 millimeters high. Now a 1U rack case, I can't remember the number, but it's somewhere around 44 or 42 millimeters vertically, and you have to subtract the thickness of the case, etc. as well. So what would happen is that this LCD, if it was turned sideways, the way we see it like this, it would take up almost the entire height of a 1U enclosure. So it'd be a tightish sort of fit. It'd be doable, but it would be starting to push it. And depending on how the front panel is done, like if the front panel is a separate single piece of metal that's attached to the rest, there would only be fairly thin strips above and below it. So it would kind of weaken the front panel a bit. I think it's just big enough that it's starting to push the limits of practicality. If it was just slightly smaller. So this is, what is it, 1.54 inch diagonal. If it was something like 1.4 inch, I think that would be absolutely perfect. So the ones that I've got at the moment are 1.3, just for reference. Yeah, Aaron said Moyne posted it. Cool. I've got to work at being better at giving credit where it's due. Because so often people point me at things and I can't remember who it was that told me about it. So Moyne posted this on Discord. Thanks, Aaron. Now, yeah, so you can see with this one costs $6.13 US and plus $4.47 shipping. Let's see if the shipping scales, because often what happens is that with vendors like this, they'll put a slightly unrealistically low price on it and then they pad the shipping. And the way to tell if they've done that is if you multiply the volume. If the shipping just goes up, like if we go to 2 and this goes to $8 or $9 of shipping, we know that they built part of the price into the shipping. So if we hit plus and it goes up a small amount, here we go, we know that this is actually like a kind of legitimate price. So if I make it go from $4.47, goes to $4, oh, that's good, $4.68, $4.89, $5.11. So there is a small increment in shipping price as we go up. Now say I wanted 50 of these, what would the shipping be? $14.76, and if I went to standard shipping, Kaneo, I've had very variable results with Kaneo, but if we just left it with AliExpress standard shipping, it's $14.76 plus $6.13. Now, it's going to have GST on it, but let's see what this is like. Okay, so if I got 50 of these, and oh yes, everybody just saw my asterisk password. So $346.79 for 50, so 346.79 divided by 50, so that's $6.93 US divided by 0.74, so it's about $9.40 give or take Australian per display, which is okay. For the smaller ones, I've been paying about $3 US per display, including shipping. So this is more expensive, but it solves the chip select problem, and yeah, so it might be worth it. Yes. So showing your non-PO box address. Okay, well, a lot of people already have that. Maybe I'll go back and edit that. Doxed myself again. So yes, many people have received packages from me and have my actual street address already. So yeah, so here's a trick. If you want to find out what my street address is, buy something from me and I will post you my street address. Except for yeah, for some packages, for local ones, it can be PO box. Yes, so this is some of the messing around that I did with the driver for the TFT to get it working. So the demo that you can see working on the driver is from this, and it's using Bodmer's library and a little modification to the user thing. It's unfortunate that there is this screwing around to make it work. You have to edit like a user profile inside the library. So there's a header file in the library that you modify in order to change the pin assignment. And you can't change the pin assignment just in the initialization of the library, which is, yeah, it's just a bit of extra stuffing around, which is unfortunate. But it works. You just saw the text on the screen. It was doing the text demo. So that's right. What I was going to do was, if I switch to Arduino, what have we got? Yeah, LCD color test. This is the one that is running right now on that LCD that you just saw. And this is an NTP client. So I'm just going to check if I've got the serial port and everything selected. I do. So let's just compile that and upload it. And this should verify that Ethernet is working, and we should see the LEDs blinking. Hard resetting. What's going on here? It is not resetting. Open an error occurred. Okay, it failed to upload. Why did it fail to upload? I wonder if it's a power issue. It could be. So we've got, I'm just checking my settings in the IDE here. So I'll do, I didn't have a, there are a whole lot of options in the Arduino IDE that aren't set by default when you change, and I don't know what it actually does. Like if you open ESP32 dev module as your profile, and you don't set the flash frequency, flash mode, all of those sorts of things, I presume that what it passes through to ESP tool is nothing, and then it just uses whatever the defaults are for ESP tool. That's my guess. Never actually looked into it, but I've just set them explicitly. So now we'll see if it can do the upload. Connecting, uploading. It says that it's writing to it. I think that's better. Oh, Mr. Fixit said, I just ordered the last 24 port button input module. I'm waiting on the URC. So it was you. Yes. Hard resetting. Oh, cool. Yes, it was you that ordered the last one. I actually have two here right now. One is yours, which I will ship out tomorrow when the post office opens. And the other is mine, because I need one here for doing this sort of testing with it. So the one that you saw on camera before is the one that I'm keeping for myself. And I'm keeping that one because when I put the sticker on one of the connectors, there was a little bit of grit or something that got under the sticker. So it's got a little bump in it, which really annoys me. I don't want to sell it like that. So I'm going to keep it. It does auto detect if you don't specify. Interesting. Thanks, Sion. Yeah, so I need to assemble some more of those 24 port breakouts. I've got heaps of the 16 port breakouts sitting on the shelf just back there. And I even have one of the 8 port breakouts. No one has bought any of the 8 or 16 port breakouts. Like zero. Oh, I shouldn't have done that sign, sorry. That was not intended to be, I was intending to do 0. That's all I was intending to do. So 0 have been sold of the 8 and 16 port versions, which doesn't really surprise me that much because I think the 24 port, if you're going to go for building a light switch controller, there's not much point building one with a limited number of ports unless you're doing it for a very specific purpose. You might as well just put in a 24 port and have spares. So yeah, last time it took me, I think it was about a day of work to assemble the 5 that I did previously. So far, I've sold 5 of them. 2 have gone to Ben, and 2 have gone to, I can't remember who it was, and 1 has gone to you, Mr. Fix-It. So yeah, it was about a day of work to assemble those 5, and I need to put in the time to assemble some more. So, oh, Doji says you could do a 2x16. Yeah, you could, that's right. Yeah, Mr. Fix-It says, I'm up by one of the 8 ports for the shop lighting. Yeah, the thing is though that it comes down to the incremental cost of doing an 8-port version. By the time you add all of the other stuff around it, the breakout, it becomes only some, you know, smallish percentage of the overall cost by the time you've got the enclosure and the controller and all the other stuff. So the difference between making an 8-port and a 16-port and a 24-port is not that significant. All right, so what am I doing? That's right, hard resetting. Let's, just for the just so we can see it, look at this. This is the, I just loaded the sketch onto it, and now you can see that these LEDs are flickering, and this activity LED at the top is the purple one, which looks really cool. It's a cool color. So you can see we've got activity going on there. The Ethernet is live. The LCD is dead. And switch back to the desktop and let's see if we actually have an Ethernet connection. No, it's browning out. Aha, okay. So what I can do now is, I wonder if the brownout is being caused by having the LCD plugged in. Nope, it's not that. I'm just going to hit reset on it. Yeah, it's browning out because I'm powering it over USB. Now, how did I have this? I'm trying to figure out how I did it when I was testing. Because if I try to power it from back to overhead. If I try to power it from PoE, it's going to have trouble with the power from the USB. So how do we get around this problem? Yeah, so I'll just show you what's going on here. It's not pretty. If we go to the desktop, you can see this is the console that's coming back from it. And that message that's flickering through says brownout detector was triggered. I wonder if I can just change the settings on the brownout detector. Let's see. Are there any options for that? I don't think we have any options. Core debug. No. PSRAM disabled. So I wonder if I powered this differently. At the moment it's coming off it's getting all its power from a USB hub, which is not powered, it's only passing through. I've just changed a setting on here and I'm going to recompile it. If I run it off a connection that goes directly, how can we fix this? What I need is a data only USB cable until I figure out the problem in the power supply. Yes. Maybe I'll just plug in the power supply and we'll see what happens. We'll see if we can blow anything up. Yeah, it's still browning out, it looks like. It is. It's not happy. All right, back to overhead. But what's puzzling me is that yesterday I was doing almost this exact same thing and it was working. So I've got power coming in on USB and we need that because we want to see the console. We want to see the result of this thing connecting to Ethernet. You can see that it's initializing the WISNet chip and you can see here the connection. It's showing these indicators are for connection. I can't remember which one it is. I think one is a connection and the other one shows activity. I'll have to look up what they are. All right, so lab supply, that's what I want. Turn on the lab supply and grab, I will get alligator clips. Because what I've done is I've just got a couple of leads. They are into this little pluggable terminal block that goes in the back. And this is coming from the lab supply so that I can connect it on here. Now which one is which? The grey, now the purple is positive, grey is negative, and if I wonder if I'm going to fry my USB hub by doing this. So if I'm going to set it to, what do I want? I'll set it to about 9 volts will do, VSET. Oh, VSET 9 go. And I'll set it to 300 milliamps. Turn it on. Let's see if the smoke comes out. Ooh, no smoke. But look at this. We've got activity on here, and this is looking much more healthy. We're no longer getting the power LED browning out. And let's see if we still have a USB connection to it. We do. Hang on. Look at this. Look at this. I'm going to switch back to the desktop. So this is what is currently coming out of the... I'm going to hit reset so we can see it boot up. All right. Resetting WIZnet board. Ethernet is connected. It's got an IP address. What this is doing is connecting to an NTP server to get time. And it's got second since Unix epoch, January 1st, 1900. Number of seconds. UTC time is 1:01:06 sleeping. So that is the... this is basically indicating success on Ethernet. So we know that we can talk to Ethernet, but there is a thing that is really confusing me, which is why this power thing is working right now. It might be that I'm slowly frying my USB hub, but isn't Unix epoch 1st of the 1st 1970? Yeah, you're right. Unix epoch is 1970. Second since, so yeah, this is not giving us the Unix epoch. That is time since January 1st 1900. You're right. I misspoke there. Unix epoch is January 1st 1970. But for some reason, NTP is calculating it based on an offset from January 1st, 1900. Yes. So, Sion says, so you have an issue on your USB power rail. I thought I had an issue, and let's investigate that a little bit further. But just to wrap up here, so what this shows is Ethernet is working. So right now, this board is connected to Ethernet, and it's got an IP address, and you can see we've got activity happening, and it's all happy. One thing I haven't actually tested is Wi-Fi on the ESP32 because I just assume that works. But hopefully now we've got wired Ethernet and we've got Wi-Fi. So you've got 2 options for communication there, plus USB of course, and whatever else you might want to plug into the second serial interface here. So lots of options. Now the John, ping it. Does that code have ICMP included? Very good question. Let's see if it does. And also, it wasn't using DHCP. It was just hard coded. So this example, 192.168.1.100. It does. So it's responding to pings. Unpowered hubs can only supply 500 milliamps divided by number of used ports. Yes, that's right. Because it's getting the power from the upstream device, and that's all it can share between everything downstream of it. So, all right, so the state of the software support for this is the official library, when I just grabbed one of the Ethernet examples, didn't seem to work. But this example that I that was online. Who wrote this? Michael Margolis. Oh, okay. The Arduino library originator. Well, yeah, contributor. So the person who actually made the change was Puce Baboon for the ESP32 with a W5500 module. And whatever the changes are, munged by Puce Baboon, that is what makes this work compared to the official stuff. So I got as far basically as a quick Google search for ESP32 and W5500. I found this example, I loaded it, I configured it, and it worked. And I have not looked into more detail into why this works and why the official library does not. So according to the documentation, the official library should work with the W5500 and the ESP32, but it didn't for me. So this is referencing the original Ethernet library, and then it's doing some, oh, and it's using UDP as well, Ethernet UDP, and it's doing some other stuff. Whatever the magic is that's in here, that's what we're going to need to replicate to get the Ethernet working properly, and then we've got to get PubSub client working. But at least the point of this is it proves that the hardware is okay. And now we can start munging around with the software to make that work okay as well. And this works okay, but I need to munge around with the hardware to make the LCD work at the same time as the Ethernet. Now, power rails, that's right. So I was just about to look at power rails. So how to do this. So what was going on before was, so I've got this little Unity tester Duvalaki. Now the way I'm going to turn this other stuff off for now. I've turned off the bench power supply, which means that we're now getting brownouts. You can see the LED is flickering here, and this is just generally unhappy. So I'm going to unplug USB. It'll now have no power at all. And what I want to do is I'm going to plug USB into this USB tester. So the other end of this cable. You can't really see the overall view, but hopefully you'll be able to see enough to know what's going on. So what we have is the controller, USB plugged in, going to this USB tester, and this will just give us voltage and current that's being supplied. Now I need to plug this in to, I could just plug it straight into the hub, but then you wouldn't be able to see it because the camera's in the wrong place. And this is the rough test that I was doing on Friday that indicated there might be a problem. But there isn't definitively a problem. So this is the USB extension cable. And USB extension cables are always dodgy. So I'm going to plug the other end into the hub, which is unpowered. And what have we got here? 3 point something volts, 150 milliamps. So, and it's browning out. So, which it was before. So we're getting voltage drop happening here, really bad voltage drop, and 150 milliamps is being drawn from here. Okay, so what should happen is I've got power. Let me see this. I'm going to disconnect Ethernet as a starting point. Let's make it as simple as possible so that we're not confusing ourselves with red herrings. So at the moment we've got power coming in via USB, and we're not getting enough power to be able to run all of this up and start initialize Ethernet, etc. So we've got a brownout problem happening. Although the interesting thing is that now it stopped browning out because it's no longer trying to maintain the link. Maintaining the Ethernet link takes a bit of power. So the WISNet chip normally tries to supply power down the line to drive the data line, and it's not trying to do it right now, so it stopped browning out. But we still have this terrible voltage drop. That should be 5 volts coming in there, and currently pulling 110 milliamps. So the next step is to turn on the lab supply to supply power down through here. Okay, so this is the theory is when external power is turned on, either through the back panel like this or through power over Ethernet, what should happen is that it'll take the power from that source and it won't take it from USB. All right, so what we should see is the voltage drop decrease because it won't be drawing all the current, and we should see the current here go down because it's no longer supplying the ESP32, etc. It would at that point just be being a data link. So I'm going to turn on the power supply. Let's see if any smoke comes out and we'll see what happens. What the hell? It's working. That all right, I'm slightly baffled because what it just did is exactly what it should do. What I just described. So the voltage drop has decreased because we're no longer drawing power through USB. We should now have a USB data connection. So we should be able to see the terminal, but the device is now being powered through the back panel power connector. So just to see if we do have a terminal, let's jump back over to here, and terminal is already open. I'm going to hit reset on it so that we get more messages. Yeah, so you can see here that we have a terminal working, which means USB is working. Okay, so right now we are not seeing a problem. This power auto selection is working exactly the way it's meant to. So it could just be that on Friday night I was too tired and I couldn't figure out what was going on. But what I thought I saw on Friday night was when power was supplied externally, the USB power source maxed out its current, like there was a short circuit somewhere. So when activating the external power source and this little power selection circuit did its changeover trick, then it would short circuit the USB power source. But now it's not doing it. It's working. All right, now one other test. In fact, when I did it on Friday, I think what I was doing was I was feeding power in through power over Ethernet instead of through the back panel. In theory, that's the same thing because they both go to the same place. They both end up coming through to this voltage regulator. But let's find out. Oh, these jumpers are off as well. Maybe the jumpers have got something to do with it. I'm just going to chuck the jumpers on and see what happens. We'll see if we get some sudden nasty stuff happening here. So this is the ground link. Nope, nothing nasty happening yet. All right, time to switch over to injecting power over the network instead of from the back panel. So I'm just going to plug this in. In fact, what should happen now is Ethernet should start working because we've now got a network connection. We've got power coming from the back panel and we should now have Ethernet. And if I switch back to the desktop and then hit reset to make it all reinitialize, we should get it to initialize the connection. Yes, and it has got to the NTP server. So that's all happy. All right, now I'm going to change it over. It's just out of your field of view, unfortunately, but I'm going to disconnect this power. In fact, I'll pull that out. We no longer have power coming in from the back panel. Instead, I'm going to inject down this cable. And to do that, I just have to unplug that cable. I've got to plug a different cable into the lab power supply. Now, I'll turn it on and it's working. Or is it? Yes. Yes, we've got no voltage drop here. We've got power coming in over Ethernet. We've got activity on here. I'm going to hit reset on that so that it reinitializes everything. What I'm looking for here is failure, and it's just not happening. What's going on? Okay, back to the desktop. So this is the console. You can see sleeping.
And in a moment, there we go. It's connected again, and it just got a an update from the NTP server. Excuse me a second. Come on, things have got to start failing. On Friday, I kept being disappointed because the magic smoke didn't escape. Hang on, I just need to clear my throat for a moment. Where is the mute button? Okay, hopefully that's a bit better. I am inexplicably baffled by success. And that is a picture of success. Power over Ethernet is working. Ethernet is working. USB serial is working at the same time. It's got to be something wrong. There's got to be. Oh, SD card was working, of course. We've already seen that. I saw that on Friday. I'm confused now about what failure I was seeing on Friday with the power supply, because this is working really remarkably well. Time to ship it. Yes. Okay, now I'm still waiting for the PoE regulators to arrive so that I can put one in here, and then we can check 802.3 AF power over Ethernet. At the moment, this power over Ethernet is like, all I'm doing at the moment is pumping, what have I got, 9 volts down the wire. And I was just checking the settings on the power supply. Yes, I'm sending 9 volts down the wire. It's currently drawing 290 milliamps at 9 volts. And so the power comes in through here. There are 2 bridge rectifiers inside this Ethernet socket. So what comes out of the Ethernet socket on the bottom here, 2 of these pins are power plus and power minus. They go across the board and come to here. That's what these bypass headers are for. And these bypass headers, when they're in place as they are now, they take that power, whatever is injected down the cable, and they pass it directly to the input of this voltage regulator. So right now this 5-volt voltage regulator is receiving the power over the cable and then powering the rest of the board. And the fact that that power is there means that this circuit is kicking in and disabling power from USB and isolating it, which is why we're getting 0 milliamps consumed on the USB connection. So it's working, I think. I still don't see any bad stuff happening. The only this is totally baffling to me, because this whole project has been success from beginning to end so far. The only thing in this which has not worked is this little breakout for the LCD, and that is a problem that I am 100% sure we can solve. We will either solve it by switching to a different module that has the chip select already exposed, or I will fix the circuit on the breakout and figure out what's going on with that. But so far, this part of it, 100% success. Come on, there's something wrong in the universe. The cable is slowly dragging it off the bench. Hopefully it'll stop there. Mr. Fixit said, Jordan Reese says, it almost looks like you're competent. I can fool some of the people some of the time. Yeah, so I've missed most of the chat. I just saw the very end. Mr. Fixit said, does that mean that this board might be close to finished? It might even be finished. I have ideas about things that I'd like to improve for a future version, but it is. DefPom said, try powering up the USB last in case it is a sequence issue causing a latch up. Fantastic suggestion.
That is a really, really good idea. And Defbomb said the USB is being loaded down a little as the voltage is dropping about 10 millivolts. I don't think it is being loaded on this side. My suspicion is that if I measure the voltage directly at the hub, it's probably about that. And in fact, maybe this tester itself, this will have a microcontroller and stuff in it. It'll be drawing a little bit of power. And what you can't see on camera is this cable here goes to here. See this blue thing? That is a 5-meter USB extension cord that is then plugged into an unpowered hub. So if we've got 10 millivolts of voltage drop across a 5-meter extension cord, I'm not exactly surprised. So, and to make it worse, what this plugs into after the 5-meter extension cord is an unpowered USB hub that then plugs into a USB extension cord that goes to my computer. In fact, it's worse than that. The other hub goes to an extension cord that goes into another hub, which is a powered one, which then goes to my computer. So we've got like many, many links in the chain to get to this point right here. So the fact that that is not 5.00 volts does not surprise me in the slightest. This is a really bad worst case sort of thing that we're doing here. All right, but you are absolutely right that it could be a sequence issue. So let's try this. I'm going to turn everything off. So I've just turned off the lab supply output, so we're no longer getting power through power over Ethernet, and you can see that this is freaked out. We're getting voltage drop and it's pulling 150 milliamps. Well, it's trying to. So what I'm going to do is disconnect this, and we'll see the voltage on this go back up. That's only gone back up to 4.15. I highly suspect that this there should be a disclaimer on this device. It should say something like, readings are for entertainment value only. It's not a calibrated scientific instrument. All right, so I'm going to turn back on the lab power supply. All right, it's now turned on. You can see this is powered up. It's getting its power over the network cable because this is not plugged into anything. All right, so here's the test. The sequence test to see if the little power auto switching circuit freaks out. I'm going to plug this in and we'll see what happens. And we now have activity. Oh, it's my dad trying to call me. So that's how you know that my dad doesn't watch my live streams. So it worked, is the summary. Okay, so just to be absolutely 100% clear, let's do the opposite. That time I applied power through DC in and then added USB. Let's reverse the sequence, although we did this earlier, but just to prove the point. So this time I'm going to apply power through USB first, and you can see that it started, but it's browning out. Then I'm going to add power through DC in, and this has gone back to its happy place. This is working. It is working. Alrighty. Brian said, I wonder if power is backfeeding through the USB to raise the voltage on the USB meter. Yeah, so that is something that should be prevented by the circuit. Not sure if we... I mean, it says, stop testing USB, you have nothing that resembles USB. That is right. What I've got is like a cobbled together mess. It's rude to USB to call this USB. It's something vaguely pretending to be USB on the end of some very long wires. So ESP32 schematic. Where are we? Power. No, there. USB VCC auto switch. Yeah, I'm not going to get into it in great detail, but the hang on, I'm going to pull it up here, desktop. So what we're looking at here is the schematic for the power supply auto switch section. So we've got DC in here coming to the 5-volt regulator, which gives us the 5-volt rail. And what else is useful? Okay, so the other relevant thing is, no, not there, over here. The other relevant thing is here. So we've got the Ethernet connection coming in here, and this is what I mean about the internal bridge rectifiers. This was one of the first ever parts that, like, the first ever footprints that I did in Eagle very early on when I was just starting to use it. I created a footprint for this hand-run RJ45 socket, and I went to the trouble of actually drawing the internal schematic of what's going on inside the socket. These days I would not go to that much trouble, but the good thing is that it's actually useful. Like just recently, as I've been working on this with this new PoE module and working out how to integrate it, it has been useful for me to be able to look at this symbol and see what's going on inside the Ethernet socket. And what you can see here are a couple of little bridge rectifiers. So we've got the internal magnetics that are included in it just here, so some little transformers. And we have 2 bridge rectifiers that are tapping off the power that is fed in, and then we have PoE V- and PoE V+ coming out of it here. So this is the output from those 2 bridge rectifiers. And PoE V- and PoE V+ come down to, oops, the field of view that you're getting on the live stream is not quite the same as the field of view I'm getting on this absurd monitor. I've just got to drag this up so that you can see more of it. There it is. That approximately coincides. So we've got the power coming here from the Ethernet socket, and it comes into this. So this DP1435 is the PoE regulator module, and the output of that comes through this Schottky diode to the 12-volt rail. And the reason for this diode is to prevent back powering of the PoE module if power is being supplied via another source. Excuse me. And these 2 things here, these are the bypass jumpers that are in place at the moment. So what's actually happening right now is that this thing is missing. This PoE regulator module just is not populated on the PCB because I don't have them yet. These jumpers are in place. So power is coming in from PoE here. It goes through the jumper, comes along here through the diode, and then it goes to the 12-volt rail. And likewise, we're on the negative side of the PoE input. It's going through the jumper and going to ground. So we are just directly linking the positive and negative PoE inputs to the 12-volt rail. And I'm not actually feeding 12 volts. I had my VREG set to 9 volts. But anyway, okay, so 12 volts. So what happens then is, so that's going to the 12-volt rail. If we go back to, is it this sheet? Yeah, here we go. So this is the DC connector on the back of the PCB. So it's the pluggable connector. Also goes through a diode just to prevent one source back powering the other. And then those 2 combine on the input side of this 5-volt automotive voltage regulator, which then gives us the 5-volt rail. All right, so that tells us where the power is coming from. Then over here we have this is the power source auto select circuit. Why do I always look? I look to the right so that I'm not coughing into the microphone, and the microphone is on my right shoulder. I don't know why I do that. It is totally counterproductive. All right, so then we have 12-volt rail here going into a voltage divider, which is going to give us approximately 6 volts because we've got a couple of 10K resistors here. So voltage divider going into the positive side of this this op amp. We have a 3.3 volt rail connection here onto the negative side of the op amp, we've got a 5-volt supply to the op amp. The output on that goes to the positive input on this. So this is like a dual package. The LM358D is a dual op amp. Dual? Yes, it's dual. Dual op amp package. I thought for a moment maybe it's a quad and we're only using half of it, but no, it's only dual. And then we have USB VCC. So this is the other place power can come from. Let's back up for a second and go to this part of the schematic. So this is the USB-C connector up here, and V-bus is power coming in from USB. It runs through a 500 milliamp polyfuse just to protect the upstream device. So if we happen to have a dead short to ground on this side, on the USB VCC line, then we're not going to let the magic smoke out of the computer. So that polyfuse should protect whatever is upstream. So we've got the 5 volts coming from USB on this USB VCC line. Okay, so back to here. We have 3 possible sources of power. We've got well, 2 at this point. 2 of them are combined, the 12 volts coming from PoE or from the back, and that is what forms this 12 volt input. And we have USB VCC here, which as we've seen is just coming from the USB line through through that polyfuse. So it then goes to this MOSFET, and it connects to the drain on that MOSFET. The source goes to 5 volts, and the gate is controlled by the output of this op amp. So the end result of all of this is that this transistor should be turned off if there is power on here. And the power is above, I can't remember the comparison of how this works. So if there is power on here, oh, I wonder if the problem is that I'm only feeding 9 volts in. Let's give this a try. So what will actually be happening is that we will be getting 4.5 volts coming in here, not the 6 volts that this circuit is meant to get. Ooh, let's change that. So VSET 12 go. No, nothing's blown up yet. So, okay, that's not the problem. That's all right. Okay, so, but just to check, I'm going to unplug this and then plug it back in, and it stays the same. I'm going to turn off the lab supply, and now it's browning this out. Turn the lab supply back on, it stops browning out, and it's all good. Okay, phew, that's a relief. I thought maybe there was a problem there after all for just a moment, but no, there's not. Okay, so if there is power on the 12 volt rail, so that's coming in from those other power sources, the result of this little circuit here is that it turns off this transistor, and we do not get power coming from, hang on, but it's got a body diode. What's going on with that? Surely power can come through the body diode, but at least it won't be back powered. I'd have to think about that. Okay. Because thinking on my feet is not my strong suit. Let's not go into that in too much detail. So we've got 5 volts here. So the upshot of it all is, if this is turned... Okay, I'm confused now because of the orientation of that transistor. So let's all just back away slowly and ignore it. But the upshot of all of this is, of this section of the circuit, should be, and demonstrably is, that when there's power on USB, it uses the USB power. When there is not, or when there is power on the DC in, it uses DC in instead. That is, yeah, it isolates USB VCC. Okay, I think that's enough of a summary. Okay, where are we at? All right, time to look at the chat. Intermittent Tech said, "Isn't that USB VCC label different in those two spots?" Ah, that is that's an interesting observation. Oh, and Johnny has already explained it. Johnny says, if power is greater than 6.6 volts, it would shut off USB. Yeah, we tried it with power with less than 6 volts. If it's, yeah, because it's referencing the 3.3 volts. That's true. It's comparing this reference voltage is 3.3 volts. Yes. So, and this is running through a voltage divider. So if power coming in from here is greater than 6.6 volts, it means that the positive side of the op amp goes high compared to the negative side. So that would be, with a bit of hysteresis, that would be about the trigger point. Sorry, there was a, yeah, DefBomb says voltage is still changing by 100 millivolts. All right. Sorry, we're talking about the label on USB VCC, Intermittent Tech was saying. Yes, okay, so that has kind of already been answered in the chat, but just to show exactly what's going on here, USB VCC here, you can see here this line, that label, in fact there are two different labels on that net and they show different things. This label you can see is attached to the net and it says USB VCC. And this label is also attached to the net and it says USB VCC /1.2A. Now, why is that? The thing is that this net, if we do if I just use the info tool and look at the net, you can see that the name of the net is USB VCC. And that's why this label is showing it. Now this sort of flag style termination label is to show a connection on the end of a net. It's a different purpose. So this label here is to show the name of the net as it is here. The purpose of this label is it's like a flag, is to show a connection point on the end of a net. And so the /1.2A means that it is going to sheet 1 and it is referenced to A. So you can see here there is the grid thing here with 2 and there is the A over here. So it's column 2 row A. So, and if we look at this one, USB VCC, it says /2.5A. So that is a reference that is going to sheet 2 and it is reference 5A. So it's in that little grid reference right there. So it's showing the link off sheet that it is going to, which can be really handy. I actually find that's very useful because it tells me, often I'll end up with something like a dangling net that has nothing connected to it if I'm messing around with a circuit, and if I've misnamed something, and if I look at this and there is no appended reference, then it's kind of a warning to me that, oh, hang on, this net doesn't go anywhere. And the other thing is that one thing I do, this is probably, it's probably a bad habit that is kind of forced by the dodginess of Eagle, but if you go to the name tool and you click on a net and it comes up to rename it, the options in here, change name of, will change depending on whether that net is the only the only one at all, whether it's the only one on the sheet, like whether it exists on other sheets, etc. So there can be up to 3 options here. It's got to change this segment or change all segments on all sheets.
And what that tells me is that there is another segment on another sheet that has that same name that's linked to it. So if we had, if I wanted to change the name, let's just pick a bit of a net. So this shouldn't be a named net. So this is N19, and you can see there are no options for changing the names anywhere else because this net doesn't exist anywhere else. And if I did a name change, I was just trying to find an example of one that's only on this sheet, but I don't think there is. So anyway, the different options that come up. So often when I'm reallocating, the place this is useful is when you're messing around with the I/O pins off the microcontroller. And I sometimes do this because when I've done some major refactoring of a project, I might have connections coming out here. Like say we had, oh, here's an example. Down here on the left, we've got some nets coming off here, and I've got named nets for IO27 and IO12, and I've manually placed this little termination symbol on here to show that they're not being used. And you can see that these don't have any appended grid references. So unless there is another net on this same sheet that has that value, or has that name, then that's an indication basically that it's not used anywhere else. But often when I'm trying to figure out assignments of I/O pins, I will do things like, if I grab I've got the rename tool here. If I click on this one, and it says change name of this segment or all segments on all sheets, I know that that is connected somewhere else in the schematic. If I click on this one, IO27, it just says new name. It doesn't give any options for changing anything else. So I know, and it doesn't even say change segment on this sheet. So I know that that net and that pin is not connected to anything anywhere else in the entire schematic. And I could delete it, or I could use that I/O pin for some other purpose. But being able to click on like the net like this and see that it is just explicitly named and there is nothing else linked to it, that's a kind of a useful thing. So yeah, at the part of a project where I'm messing around with all of the I/O allocations and things, I often find myself just clicking the rename tool on different nets as an indication of whether they go anywhere. Now that is, as I said, that's probably a very dodgy thing to be doing, and it's kind of, I do that because of limitations of Eagle and being able to determine whether a net is connected anywhere else. But it works. It does what I need. All right, now. Oh, Jack's Tech said, not going to lie, I thought that it was an amp rating. Yeah, it really looks like it because it's got the A on the end of the thing. Like I think that one said USB VCC / 1.2A. It really looks like 1.2 amps. That is deceptive. Pro Engineer said, am I crazy or is that MOSFET backwards? Yes. I'm not sure. Yes. I'm not going to look into that right now anymore. Okay. Mr. Fixit said, so the bottom line is if I download this board and have it made and assemble it, I should have a working switch input rack. Well, apart from a bunch of software development. And, yes. And also, you should buy one from me, please. Okay. So DefPlum said, the LM358 may not be going rail to rail enough on the gate to fully switch on the FET. Check the op-amp output voltage between both states. It may not be switching the FET properly. Cool. Thanks, DefPlum. I will do that. I'm not going to do that right now on the live stream, but that is a very interesting thing. So what I might do is, with the lab supply connected, I will put the, maybe put a scope on the output and then slowly turn up the voltage and see what happens to whether it's switching the FET, and see if there's like a, I should be able to see the
the changeover voltage. Like if I start with the lab supply, so say USB connected and the lab supply connected, and I set the lab supply to some really low voltage, like 3 volts, at that point the op amp should not it should not be isolating USB. And then if I slowly crank the voltage up, it should get to the point where it trips, and then it'll switch the transistor and isolate USB. So it'd be interesting to actually do that and see the point where it goes over. And oh, Scott said also try plugging your USB directly to the computer. Yep, cool. Oh, Station 240 said, yeah, I had a project I needed to switch to a rail-to-rail op amp to get it to work. Yeah, so the circuit that you see here, here, this circuit, that is the circuit that has been on every single Arduino DH1000 and what was there? So there was the, oh, it was on the Minerva as well. So every Arduino that has been, oh, and the NG, I think, had it. So that would have been around, when would that have been? 2007, maybe? I don't know. I'm no good with remembering specific years of things. But yeah, there have been many millions of Arduinos shipped with this specific circuit on it. So it is well tested. It's just my implementation on this particular board that hopefully is accurate. Yeah, so I'm trying to think of how many. So it's also, this same circuit was on the Freetronics 2010, and it's on the 11, it's on the Ether 10. What else? It's been on a couple of other boards. So I would personally have shipped, trying to work it out, I think it's in the order of 200,000 boards with this circuit on it. So yeah, I've kind of tested it a bit as well. But sitting here looking at it now, my first impression is that this transistor is backwards. Anyway, yeah, so, so switch out a relay. Sorry, I'm looking at the chat now as well, trying to catch up. Yeah, so Pro Engineer said the new stuff that's in the beta releases of KiCad is amazing. I can't go back to the standard release now. Yeah, KiCad has had so much development in recent years. It is amazing. I've tried it a couple of times, used it a couple of times. I've worked with other people on projects where they've used it as their primary tool, and I've basically just been kind of playing along and watching what they're doing. And it's some Freetronics projects, like some Freetronics products, are actually designed in KiCad. Like the Ether Duo was designed in KiCad by Angus, actually. So Angus Grattan from Espressif. Back before he worked at Espressif, he designed the Ether Duo in KiCad for Freetronics. So, oh, B. Edmondson, got to run. Well, I'm going to have to run soon too. It is 11:48, getting close to time, and I'm not going to say who it is because I don't want to dox anyone, but there is a birthday lunch happening today. It's not mine, it's someone else's. So I'm not really going to be hanging around beyond 12. I really should be going and going to a birthday lunch. But B. Edmondson, thanks for coming along. Chip, yes, lunchtime soon. Johnny, Mr. Lunch is not around. Well, when Peter isn't here, Chip, which is Longflare, is the honorary, is the honorary lunch police. Mr. Fix-It, turning 70 in October. What? October birthday coming up. Ah, well, we will have to get out the party poppers for your October 70th birthday. Oh, Dodgy says, got Binky to watch. Project Binky, have they just released a new episode? I'm way behind on Project Binky. I watched a whole bunch of the early ones, and I'm many episodes behind. But Project Binky is cool. Makes me want to go and get a cup of tea. Yeah. So, all right. Given my other obligations today, I'm going to wrap it up. I may even wrap it up early, but just thinking about what needs to be wrapped up. Okay, things to do. Oh, Mr. Fixit says, happy birthday, John. No, it's not my birthday. My birthday was a couple of weeks ago. No, this is someone else's birthday. But I'm not going to say who it is because I don't want to dox anyone. Johnny Bergdahl, 3:50 a.m. Do I watch Blinky or do I sleep? Well, if you put on a nice cup of tea, you could stay up and watch Binky. Maybe you should save it for when it's not 3:50 a.m. Some call it fun. Don't forget to call your dad. Thanks. Yes, he will probably have been calling my number in order to say happy birthday to the other person. So where this is at. Okay. Things to do. I need to investigate the LCD situation. I was worried that we had two problems to solve, the LCD and the power. I am going to investigate the power some more. I'm going to do that thing where I watch the state of the MOSFET, so the output of the op amp, and slowly bring the voltage up and see where it switches and see whether it actually switches hard, etc. But that's kind of to satisfy my own curiosity now at this point because it's working. And I'm not sure what I was seeing on Friday when I plugged it in, and it could be as simple as I had the current limit set too low on the lab supply. In fact, I think I might have had it set for like 200 milliamps or some low thing because I was trying not to let the smoke out. And the lab supply probably hit its current limit, which then caused it to drop, and then the auto switching circuit would have not been very happy. So it could have been as simple as that. Just supply some more milliamps into the DC input and it's all happy and stable. Yeah, so I actually don't think we have a problem with the power supply auto select. That seems to be doing oh, Aaron says 6 volt 300 milliamps if I remember rightly. That could be. It's quite possible that I was feeding 6 volts at 300 milliamps in from the lab supply, and in fact that would be low enough that the op amp wouldn't have actually triggered because it's dividing it in half, and I would have got 3 volts going into the op amp against a 3.3 volt reference. Yeah, okay. I think I've talked myself into it. Aaron said, what are my early ideas on URC v2? Now, I have one idea in particular. So I'll get back to that. That can be the final thing, just before I sign off. So I actually don't think we have a problem with the power selection circuit. I think I fooled myself into thinking there was a problem because I was at the end of a 3-hour assembly live stream when I tested it on Friday, and I just screwed up. I don't think I had the power supply set properly. So the only thing left so far on the URC is to test the power over Ethernet regulator module, which hasn't physically arrived yet. I just don't have them. What I could do is patch in a Silvertel module, because I do have Silvertel modules and functionally they should be almost the same. I could just use some jumper wires and connect it, but the other modules could arrive within a day or two anyway. So if they don't arrive, then I might patch in a Silvertel module just to test it and to prove that the 802.3 AF PoE works okay. But that's kind of a secondary thing. The other thing to solve is the LCD. So I'm going to do some debugging on that, and what I'm going to try is changing the chip select running to the buffer, so that instead, I'm not sure which order I'll do it in because it's going to involve a bit of track cutting. I'm going to try two things. I'm going to try, because it's a dual channel buffer, I'm only using one channel at the moment to disable the data line. I'm going to also disable the clock line and see if that works. And I am going to disable only the clock line and not the data line and see if that works. So a bit of tracing, a bit of cutting and jumpering and some investigation with the scope, and I should be able to get that figured out. But it may not even be necessary to do all of that, because if we end up going for an LCD module that has chip select on it, this isn't even a problem. So it comes down to a decision about which module to use. The reason that I like the modules that I've got at the moment, the 1.3 inch modules, is that they are really cheap and physically they are just the right size. They fit the space really nicely and they give a display that's big enough, but it's not so big that it is kind of awkward in the single rack unit height. So ideally I'd like to go for around a 1.3 inch display. I think that's kind of the sweet spot. So if I can overcome the chip select problems and make it work with the 1.3 inch display, that'll make me happy. If we have to go for a different display, well, we can do that too. Oh, Scott said, properly designed Superhouse LCD module. Yeah, that's the other option. I'm trying not to put too much burden on myself in terms of assembly, and assembling little custom LCD modules with the fiber connector, like the flex connector, it's a bit fiddly. So if I can order it. Oh, Mr. Fixit asked, could I buy one of your boards from you with my shipment on Monday? Ooh. Given the amount of success that we've had so far, I'm kind of inclined to say yes, because so far it's working. And like if we had things that still needed to be patched, yeah, so okay. Oh, Aaron just said, I sent you a link in Discord that's cheaper and free delivery. Nice. All right, so investigating the LCDs. That is pretty much on the top of my priority list right now, because the main board, inexplicably, it's working. We've got to solve the LCD problem, and then we need a case to put this in, which is a big, big question. Aaron said Q jumper. Yes, I know, but Mr. Fixit has just ordered a 24-port module as well, which is about to ship. Okay, but this does raise an important question. Maybe what I should do is make these boards available to buy right now, because it is working. I have parts, I can assemble them. The only reason that I haven't actually made them available already is that I hadn't really got through fully testing it. So far, the tester seems to be working. Yeah. What I'll need to do though is put a caveat on the on the web page where you buy them, because as you've seen, we do not have software that is ready to go on this. You can't buy this and the 24-port module, put the jumper wire, like the cable in place. And yes, Cable Tie says, get your customers to finish testing. Exactly. So it needs to be an informed decision. So Mr. Fix-It says, I'll take a chance. If you want one and what you've seen so far of the testing that we've done on the bench gives you enough confidence that you can order it and think that, yes, we're going to resolve the software issues as we go, then okay, I'll sell you one. Open up pre-orders, yes. All right, I am going to go because I need to go and wish someone a happy birthday. But I am going to follow up with assembling some more, and I will create a page for it with a disclaimer. I will check out the LCD links that have been put in Discord. Thank you for that. And thank you for coming along today and making me feel a whole lot better than my low energy self was when I started this live stream. I hope you're having a good weekend. I'm having a pretty good weekend. Yeah, Johnny says, we'll fix any issues in software. V2, okay, a couple of people have said that. This will be very quick. It's been mentioned a couple of times, the possibility of putting a Watchdog timer on this. So there are two ways that could be done. I could either build a Watchdog heart directly onto the board, or I could put a header on it where you could add a Watchdog. The requirement for doing that would be exposing the reset pin and a GPIO that could be used for the PAT connection back to the Watchdog. So my inclination, I actually don't think we're going to need a Watchdog on this necessarily, but provided we can make one fit, it's zero cost to put the header on. So at least you can use one if you want to. So what my inclination is for that is for V2 is to add a 4-pin header that matches my existing Watchdog module. So it'll just be like a 1x4 header, and I'll need to find somewhere on the board to put that on, and that way if you want to populate it, you can put a socket on there and then put a Watchdog module on, but I wouldn't populate it by default. And then Aaron says, I think you already exposed those. No, I didn't. Reset is not, reset is exposed on one of the IDC headers, but it's not on the, if I switch to this overhead view. So this is the extra IO on the side. Reset is not on this header. And so we've got 3.3 volts ground. So what we need is reset and one GPIO for the Watchdog timer. So what I could do is probably put something like a 4-way header maybe here, just below the Superhouse URL. And that 4-way header would be for a Watchdog timer that could then sit in over the top, like it could overlap the logo and the thing here. It would just, you could plug it in. Anyway, I can find somewhere to put a 4-pin header on there, and that would solve that problem. And it's essentially zero cost because it's just 4 extra pads on the PCB. Yeah, never forget to feed the Watchdog. That's right. So you need the GPIO coming out from the microcontroller in order to keep patting the dog so that it stays happy. And the other thing, what I'm thinking of doing, so we've got this power header here. At the moment, this is just exposing 3.3 volts with a current limiting resistor for a power LED on the front panel. What I'm thinking of doing is maybe putting a WS2811 RGB controller chip on the PCB and then put a 4-pin header on here so we could have an RGB LED in the front panel bezel. And then we could do things like show status with the color of the LED. However, I don't think that's really necessary because we're going to have an LCD anyway. We can display lots of information on that. We can show Wi-Fi status and IP address and all of those sorts of things. So it's not absolutely essential, but I think it would be nice to have a multicolor LED in the front panel instead of just a blue power indicator. But if we But that introduces other complications. Like if you've got the pass-through version of this and you've got a Raspberry Pi in there instead, then how do you control the RGB LED? So anyway, it's that's all a complicated decision. It's actually technically really simple, but it's just more from a how would this be used point of view. All right, okie dokie. Oh, Matt Smith says do it with an SK6812, not a WS2811 or 12. SK6812, I have never heard of that. SK6812. I am sticking that in my data sheet. So does that come as a surface mount chip on its own, or is it only, because the reason I use a WS2811 is that I can drive an external RGB LED. Anyway, cool. I gotta go. I will talk to you all next week, or SK6812 is a WS clone but better. Yeah, but is it a complete LED? Because I don't want a complete LED. I just want the driver chip. Okay, cool. Yeah, I just want the driver chip so that it can go into an RGB LED mounted in the front panel. Yes, I am going to go. So, thanks everyone for coming, and have a great week / weekend or whatever, and I will talk to you all soon. And make sure you come along to Discord. If you're not on Discord already, superhouse.tv/Discord, and there is lots of ongoing conversation about the project and other fun things. So, where's the end button? Down there. Okay, all right. Bye everybody.